on, I'm not ready.
Alright, that was the first thing people are going to hear.
Wait,
Hello,
what's happening?
welcome to my UE4 Masterclass. We're going to be covering basic Unreal Engine sort of tips and tricks. Nothing very advanced, just stuff you guys can hopefully learn and take into whatever you might be experimenting with. So we're going to be doing stuff with dynamic materials, basic communication between blueprints, customizing the player character settings, and some basic UI exploration. It's just to help get people who are booting up for the first time over the initial hurdle of, I want to do something, but I have no clue how I would go about doing it. So for the purpose of this tutorial, we're using Unreal Engine 4.22. I think I'm using 4.22.2. And yeah, so has anyone got any preference on the thing we start off with first?
I think you can go with whatever you want to approach first.
Alright, well,
Dynamic material.
let's do dynamic materials then.
Oh yeah.
So let's create a very quick basic material. M underscore dynamicist.
Nice, dude.
Thanks. Alright, and we're just going to make a to bring up a quick single vector parameter, single v1 parameter, just hold one on your keyboard and left click, and that'll bring this useful little node up. And if you right click on it and click convert to parameter, it's now a parameter. Let's rename it to opacity. And you may notice immediately we can't plug it in, it's just grayed out. So right click on this, or just left click rather, and on the bottom left here, there'll be a material domain. So the surface to decal, we want to leave all that as is, but for opaque, for blend mode, we want to set it to translucent. And now, because our default value is 0, and it's plugged into opacity, there's currently nothing visible. So let's make the default value 1. Set the slider max to 1 for convenience sakes later on. And now it's just a black sphere. So if you hold 3 and left click, you'll get up your vector 3 majigger. Not very good with technical terms. And if you want, we can do the same thing. So convert to parameter in this one color, and simply just have the white node here plugged into base color. And let's say for test purposes, I'll make it now we've got a nice, very ugly looking unlit green material. So save that, and let's apply it to something in our scene. Oh, actually, before we do, so this is a basic material, and its default parameters won't change on the fly. It has to recompile everything when it's edited. A way to get around that, so we can use materials in real time, change materials in real time within gameplay, we want to create a material instance. So just call it mi green giant. Give my naming scheme, and apply it to this box. And once it compiles all the shaders, now applied. And you can see, if we open up the green material instance, it looks very different from our regular material menu. And that's because it's not material, it's a material instance. So any changes we apply to the material in here will automatically be applied to all material instances of that material, which makes it really useful when you're having multiple sort of material instances based on the same logic, certain things. But the best thing about material instances is obviously the real-time updates. So if we enable our color parameter to be edited, you can see that we can change the color and it's updating in real time without having to recompile any shaders. And same with opacity. You may notice shadow still there. That's because it's part of the built lighting. Okay, so we've set up our material instance, but when we run around, material still isn't doing it. So, let's create a trigger. So, what would be the best way to go about this? A level blueprint or a custom? Let's make a custom blueprint. Okay. So let's create a new blueprint, and we'll just call it BP underscore green box toggle. That up.
Just quickly,
Oh,
I didn't
yeah.
notice what blueprint class you used.
Just a regular blueprint class actor.
Okay, is actor the default one we should do?
Unless you know specifically what you're doing, actor's pretty much the go-to one that you're just going to be using for everything.
Okay.
Right. So go to the event graph. We can ignore the... Actually, no, sorry. Go into the viewport, and we're going to add a component. And we are going to search for a box collision. And now there's an invisible box. And on the right-hand side, we have our details. So it all seems all right so far. Scroll down, and we want to make sure our collision preset is right. So right now, it's overlapping all dynamic, and it's generating overlap events, which is exactly what we want. So basically what this means is everything in the game, pretty much, this will overlap with, which means things can walk inside it and out of it without being obstructed by it. And whenever something does, it will generate an overlap event. So just compile that quickly. And down here, these are the events we'll be mainly interacting with. So because we're generating overlap events, we can interact with begin overlap and end overlap. We're probably going to be using both of them, so let's add both of them to our event graph. So now they're down here. So we want to set it so when our character walks inside the trigger, they can interact with our box. Now, for those of you in my class that followed David's tutorial a few weeks ago, this should be relatively familiar. But this is basically just walking inside range of something and you can interact with it. So we're going to set it so when our player character walks inside the trigger, something happens. So to do that, we need to test what actor is inside our blueprint. And a really easy way of doing that, super easy, it's built into the engine. You just type get player. Oh, sorry, Regalian Crow, can you change your thing to push to talk?
Yeah, but my things.
Thank you very much. So what you may have missed is we've created a material and a material instance. Really basic stuff, just made a material and added two parameters, one for color, one for opacity. And we then created a blueprint and just put a box collision inside. And then on the details panel on the right hand side, we've gotten two events, begin overlap and end overlap, which are now available here. A useful part of Unreal Engine, because obviously you're going to be referring to it all the time in your game, is the player. So there's literally a node built in for just get player character. Now you may notice there's two. There's get player controller and get player character. For the purpose of this tutorial, we're only going to be using get player character. There is a difference, but it's quite difficult to explain. But actually, okay, no, there is a difference, and we will need to explain it. So get player character is our physical character within the scene. So this, what I'm moving around right now, is our player character. What our player controller is, for lack of a better term, is effectively the literal keyboard and mouse. So it's what controls the inputs and then sends them to our player character. By default, they're basically treated the same, depending on what default project you opened up. But for the sake of this blueprint, there is a really important difference. Because what we're going to be interacting with is is enable input. And as you can see here, this interacts with our player controller, not our player character. We're just going to plug that in there. And now our target is obviously self, because we want this blueprint to control this new input. But we want to make sure it's our player character walking into the sphere and nothing else. Sorry, the box rather. So we're going to do a little test here. So just equal object, and we're going to see if our other actor is equal to our player character. Now, I know it's weirdly confusing and but I hope I explained it as well as I could. So now this will activate true or false depending on if it's the character that's stepped aside or not. So before we enable input, we need to do a branch, which is basically just an if statement. So on event begin now overlap, if the actor that overlaps this object is our player character, then this will be true. Otherwise, we don't want it to do anything, so we can leave that empty. Oh, I've received a... sorry, just received a weirdly distracting message. Where was I? Oh yeah. So, as parts of our begin overlap, so we've got our enabled input and everything's perfect. So now we need to choose a button that will interact with our object. Now, most tutorials would probably just tell you to input F key, and it will just tell you to do it from here. This is a valid way of doing it, and I wouldn't fault anyone for doing it this way, but I personally do it another way, purely because it's easier to reference, you'll get less confused down the line, and it's just good habit. So, we're going to go into our project settings in the Edit tab, and that opens up. It should look something like this. And we're going to go into our input, which is in the Engine tab. And you'll see here we have our action and axis mapping. Now, all of these default ones are just what make the player character work. So there's move forward, move right, turn, look up rate, and look up. And here we have jump and reset VR. So obviously our jump button is space. It's a binary thing. You just press it and it goes. But move forward and move backward are directions effectively. So the forward scale is W, the backward scale is S. Really simple, and you can have multiple inputs plugged into it, which saves a lot of space. So we're going to be creating a new action map, because it's just a button we push, not an axis, and it's just going to be interact. And I'm going to make it our F button. So you don't need to press save or anything, it's just automatically applied. So close that, and we've got our new input. So now, if we go back into our blueprint, make sure it's compiled, and now we can just type in event, interact, here we go, and now our new input is there available and ready for us. And so obviously all the code in here will run based on if you've pushed our interact button, which for me is F. So now that input is enabled, for this blueprint, when you walk inside, it will be able to detect this input. If you don't have enable input activated, when you push this button, nothing will happen, because this blueprint isn't our player character. By default, the player controller only controls the player character blueprint. So, okay, and we want to make sure that when you leave our box, you don't still have control. So basically the exact same thing that we've got here, almost word for word. We're going to plug in other actor, check for there, and our player controller. But you may notice this is still enable input. So here we want disable input. And we want to plug this back into our player controller. So this should successfully activate our inputs when we walk within our box. So now we want to actually do something with that input. So this is where we're going to start interacting with our dynamic materials. So compile, save. Now, let's go back into our viewport and let's create something for us to show our blueprint. So I'm just going to use a sphere for now. I'm not sure what the scale is. I imagine it's quite. I'm going to make our collision box bigger because I have a feeling it's going to need to. So if we go to our sphere, there's our mesh. We're just going to leave it a sphere, and this is our material. So if we search for a material to use, so your first instinct may be to have it original material, Dynamicist, but because we want it to adapt in real time in engine, obviously we're going to use our material instance instead. So mi underscore, can't find it. Another useful shortcut, cheeky little bit of UI for you there. If you have it selected in your editor, you can just press this button and it'll automatically grab it for you. You could also just drag and drop. There's loads of super easy ways to do it. So now we've successfully applied our material, but it's still not doing anything. So there's two ways of doing it, but I think for some reason one of the methods doesn't always work, so I'm just going to show you the always work way of doing it. So we want to go into our construction script. The difference between the construction script and the event graph is the event graph only happens when the game is running. The construction script is code that runs outside. So if I have a thing in my construction script that allows me to, for example, change a character's shirt color, but I only want it to be done obviously as part of the editor tools, then it would be done in the construction script. And that's exactly, well, very similarly to what we're going to do here. So we're going to set a dynamic, alright. So we're going to create dynamic material instance. And to make sure we know which one we're referring to successfully, we're going to drag our sphere onto our construction script graph and just oh, alright. Dynamic material. I'm not sure. Anyway, we don't want it to be for our box though. Dynamic sphere. There we go. Okay, so this is what we want. So you may notice there's a thing called element index. This determines which selected material of the mesh you're editing. So right now we only have one slot, which is element 0, so we're just going to leave that as is. You don't need to change your source material because it's already got one. At least I believe you don't. If it doesn't work later, we'll know why. And pretty much all of it you can leave as default because we're just going to be referencing it here. So compile and save that. Now we're going to mess about with some parameters. So if we go over to our material, this is a vector parameter because there's three values, R, G, and B, and for some reason A, but we can ignore that. A stands for alpha, which is this little node here, but we're not using it. We could do if we wanted to and plug that into opacity. For now, we'll just leave it like this. So we've got two parameters, a vector parameter and a scalar parameter, because this only has one number stored within it. So in our input action interact, we're going to set our scalar parameter. Not on that. Scalar parameter on material sphere. Here we are. And now our parameter name is opacity. And now we can determine what the value of that scalar is. So 0 would make it invisible. Cool, that's what we want. But for a fun little bit of thing, another really useful tool within Unreal is called a flip-flop. And this is basically just when it receives an input, it will swap to A. If it receives another input, it will swap to B. Another input, it will swap to A, back and forth, back and forth. So it's really useful for setting up toggles, which is exactly what we're doing here. So we've got our set scalar parameter for our opacity. On option A, we're going to have it on 0. And for our other option, we're just going to set it to 1. Pile and save that. Oh, didn't like. We need to have it plugged into our sphere mesh, that's why. Now it should work. So now, if we drag our box sphere toggle into our scene, press G to hide all the crap, and this is basically just the game view, so it removes all the wires and visual boxes, nodes and stuff. And now we've got our green sphere. So if we press play, walk in, press F, and there you go. So when you're inside the range, it toggles the light on and off when we press F. Very cool, very simple. You can apply that to hundreds of things. But now, we want to get a bit creative with it. Let's say I want to have it rainbow through all the colors. So let's go back into here, and we're going to do something a bit crazy, but it's possibly my favorite feature within UE4, and that's timelines. So we can probably just have it run off event begin play. So let's create a new timeline. So add timeline. Let's name this our spectrum cycler. I spelled cycler wrong. And this is going to control whether or not our material's color is a certain way. So if we double click on the timeline, you'll be met with this just grey mass. So at the top there's lots of little buttons. The length is very important. It determines how long the timeline is and how much room you've got to mess about with it. But there's also loads of checkboxes in here. The only ones you'll probably ever be interacting with are autoplay, loop, and maybe ignore time dilation if your game mechanic revolves around slowing down the game engine at any point. So we are going to create three float tracks. I'm going to make this our red, this our blue, and this our green. Now you may already be seeing where I'm going with this. So let's say we want it to do a full cycle, I don't know, every 3 seconds. Let's make the length 3. And you'll see there's these 2 buttons here. So it's very easy to get lost and confused in your timelines. So you'll probably be using these a lot. So you can hold right click on the graph to move around. And when you start having keyframes, these will be very useful. So I'm going to add a keyframe for red and set the value to 1 times 0. So this will mean at the start of our timeline, our red value is 1. And I'm just going to do times 0 value 0 for the other 2. So it's exclusively red. Now I'm not going to go too into depth with this to make it a perfect cycling rainbow. You guys can just have fun with that on your own. But I'm just going to show you how you would do it if you wanted to. So after 1 second, it will stop being red, and it will have cycled to blue. Oh, sorry, I forgot to. So now, over the course of the first second, it will be fading from red to blue. So hopefully we should have a nice purple halfway through. And obviously once that's done, we're going to have our blue. After 2 seconds, go to 0, and our green after 1 second will begin fading into what's the word? It will begin fading in, basically. And after that, we can have it reset to 0, and our red can fade back in. And hopefully we should have a really nice cycling spectrum. I have no clue what it will look like, but hopefully if I'm right, it should look like something. And because we want it to cycle, we're going to enable our loop. So we've got our red, green, and blue value, red, blues, and green values here, but they're currently not plugged into anything or doing anything. So we are going to use our dynamic material update. Dynamic material. We want to set vector on material sphere. There we go. And our parameter name, if I recall correctly, I'm starting to lose the ability to speak. It was called color with a U because I'm not American. So you may notice that these won't plug in right. So there's 2 ways you can go about doing this, and it's all down to personal preference. We can either make a vector which will take our values here and plug them into this. RGB, isn't it? So we actually want to plug that like that. It doesn't matter too much. Yeah, doesn't matter. So yeah, there's 2 ways of doing it. We can either make a vector, or you can right-click on this pin and click Split Structure Pin, and you can just plug them in directly. Because I just feel like this looks neater, I'm going to be using our make vector. So compile and save, and that will start on event begin play. So update is an event that runs every single frame. So every time our timeline does something, it's sending a signal to update our value for our material. This isn't the cheapest way of doing this. Personally, if I had more time, I'd have it cycle through spectrum within the material. For the sake of very basic mechanics, it's just as good a way as doing it. And because our event loops, this will pretty much be running eternally. So, save, and now, as you'll see, nothing's happening. That's because event begin play, which is what we've got it plugged into here, runs when the game starts. Event begin play occurs when the object it's attached to is either spawned or it begin, or like the game starts, whichever comes first. It just basically happens when the object realizes it's in a game. If we click play, it's cycling our colors.
Whee!
Way. Alright.
Pride ball. Pride ball.
Fight ball. Alright, I won.
Eat ball.
So you may notice that when our character pans over, it still collides with the sphere, and that's because it's still actually there, it's just invisible. So maybe we go into our material. Instead of opacity, controlling our opacity, let's instead our color to a bit brighter and a bit nicer. I'm going to set our opacity to a brightness multiplier. Let's just do a multiply. and plug that in. Plug that into a... And I'm going to disable opacity. I would rename it at this point, but I don't want to have to go back into our blueprints and rename it here. So I'm just going to leave it as is for now. Save that. And now it should have the same effect, but what we're going to do is add one more step. So we're going to have it multiply by, say, 10, and then plug in. So now it glows real bright. And now instead of going invisible, it just goes black. And if you want to, you can hook it up the exact same way. So we could set a variable, a graph here to control the opacity in time with this timeline. You can use it for pretty much anything and everything, and it works so well, and it's great, and I love timelines. And with that, I think that's pretty much our dynamic instance, our dynamic material tutorial. Does anyone have any questions or wanted me to slow down at any point?
You're doing great, baby.
No questions? Alright then. We can move on to the next thing. So this is probably the thing I struggled with the most. And that's getting two blueprints to talk to each other. So what would be the best example of this? Okay. Let's make a lift. So I'm just going to quickly hit this 4, scale it down, and just plop it over here. So, a lift wouldn't be the very best example. Oh, actually, to show off timelines a little bit more, that's another thing you can do. So if we go back into this, the BP, we can make it so the orb even floats up and down. So let's create a new thing called DU, and so starts at 0, ends at 0, and time at 1.5. It's at it's gained 50 height. So as you can see, I can't find our keyframe. I'm just going to press zoom to fit vertical, and now it's all fitted in nicely. After that, I'm going to create another frame at 3, sending it back down. Now this is a very sharp thing, so I'm going to quickly assemble that for us so we can see. So to move it up and down, we want to use relative location. It's very important that it's relative. Relative makes it so it moves the sphere within our blueprint world. So right now, its current location inside the blueprint is 0, 0, 0. It's completely fine. But if you set it to use world, instead of it being 0, 0, 0 in the blueprint, it would be 0 in our world, which would place it underground, which is not what we want. So it's very important that you use set relative location. And we want to have it plugged into after this because we want it to update every frame because it's part of our timeline. So as for our new location, we can ignore X and Y because we're not changing those and we don't mind them being at 0, sorry. But say that wasn't the case for you. What you would want to do is get relative location, and then you can plug it into there. and that gives you the XYZ values you've given to it in the viewport. But we only want X and Y. So again, what we can do here is split our structure pins, and we can choose to only use X and Y, and then the Z we can take from our timeline. So now it should move up and down quite slowly, but yeah. But you can see it changes directions quite sharply and quite suddenly. We want it to sort of ease in and out a little bit to just make the movement look slightly more natural. So go back into our timeline, and there's a super easy solution for this. You literally just right click on the keyframe, just click auto, and that creates a handlebar tangent for it to curve through. Let's create one here. Now we've got a really nice, well, semi-smooth transform. Now, if we look at it again, you can see it slows down ever so slightly as it reaches the tops and bottoms. And that's all controlled using just one neat little node. Now, obviously, if you put too many graphs in there, it can get a bit unwieldy and a bit confusing as to what its intended purpose is. So I'll leave that up to your personal discretion. So what was I... Ah, yeah, the lift. Oh wait, no, I just showed you with the ball. Okay. So, the next thing we want to look at is communication between blueprints. Now, let's say instead of it wanting to use our interact mod, I'm trying to think of the best example I can do this. In the game I'm currently working on, I used it, for example, when I locked onto an enemy. So when you pressed an input on the player character, a bunch of stuff happens and it calls a function that will then be casted to a certain thing, and if it has that function enabled, then it runs that event. So I'm just going to show you how you would do it. Okay, so the first thing we need is a new blueprint, but we're not going to go into blueprint class this time because we're not making an actor. Instead, we are making a blueprint interface. Blueprint interface is a collection of functions, name, presentation, that other blueprints can interact with when told to. So we're going to select that. BPI underscore. Actually, okay. Deanna had a good idea earlier. Let's make our thing be able to attack. So BPI underscore attacked. Actually, let's just name the BPI itself combat. Open it up. Now, 90% of this screen, we're not making any important functions. We're just going to be creating events effectively. So pretty much all of this we can ignore. And in the top right, we'll have our new function name. And we can just call it attacked. And we don't need any inputs or outputs. Compile, save, that's done. So for this next part, we're going to go into our third person character blueprint, or whatever your player character is. And we're going to say, should we make another, ooh, I know what will be fun. Should we make a Goomba stomp? Let's make a Goomba stomp. Okay. So when you jump onto something, you deal damage. Let's do that. Okay. So I'm sure there's better ways of going about it, but how I would go about it is creating a box collision and just putting it a little bit below our character. And we can just rename it to our... Make sure it's the child of our capsule component so it moves correctly. And click compile. I don't know why my details panel is changed. And just make sure our collisions are right. So, so here's a problem. with its current settings, it will be colliding with our character mesh. And we don't want it to do that. We only want it to do that when it collides with others. Now, this is one of the weirdly difficult this is just one of the weird things that, for some reason, is much harder than it should be. Like, in Unity, you can literally just set it to not collide with parent, but you can't do that in Unreal, that I know of. So, what we could do is set it so... let me just quickly experiment. Project setting... collision. Okay, so if we make a new preset, name, oh wait, no, we want to select we want to create a new object type. So maybe it's here. Ah, perfect. Okay, so we want to create a new object type. Let's call this one player. And we want to make its default thing to block. Accept. Now, this is my first time doing it, so let's see if it works. So compile. Now, collision presets. Still not here, but so perfect. So now there is a player channel here. So we're going to make it custom. So we want it to do exactly as it's doing, but for our player, we want it to ignore. I need to actually apply this to our project back home because this is big brain of me. And we want to make everything else a player. So object type, we want to set it to player. And pretty much all of this we want to set it to player. Camera boom. Follow camera. Oh, so just our meshes next. We want to set this. So right now it's by default character mesh. We want to change that to custom player. Perfect. So now our Goomba zone will overlap with everything in the world except our player, which we've just told is our capsule collider and our mesh. I'm hoping this works. If it does, I'm a genius. Okay, so let's create a basic bitch character. Actually, you'll be able to do it yourselves. For now, I'm just going to do it with this since we've already got it up and running. Not BPR. Here we are. So we want our sphere to be physical. Yes, block all dynamic. And we just want to make sure it's a world dynamic type object. Perfect. So we know, because it's world dynamic, that our Goomba zone will overlap with it. And because we have generate overlap events, it will detect that. So, let's go back to our third person character. Now, let's grab some events. So, on component begin overlap. Now, this is where it would be a bit tricky. So, I'm going to set up tags. Now, this is getting much more complicated than I originally intended, but this is just, again, like, it's super useful, and if you ever focus on making a game mechanic that interacts with certain enemies, this is how you're going to want to do it. Actually, no, I won't set up tags, because that's a whole nother tutorial. Instead, let's just get other actor equals, and let's see if it's... Okay, so a problem I just thought of. Our Goomba zone will overlap with our box collision. So before you even reach it, it'll do it. So We go to set it to trigger. Basically the same. So we could create another collision type, which I'm sort of inclined to do. So anyway, yeah, you know how to set that up, so if that's what you want to do, you can do that. For the purpose of this, I'm just going to have it so it specifically looks for a component. Now, how do we get specifically our sphere inside this blueprint to be referenced here? There's a few ways you can do that. I am going to see if this way works. So we are going to cast. So cast basically allows you to pull variables from other blueprints. We're going to cast to our BP underscore greenbox toggle. Now, we need to tell our blueprint which instance of greenbox toggle it's actually going to be referring to. And thankfully, we know exactly which, because that's going to be the one we're overlapping. Actually, this is probably the way you would best do it, yeah. So now, as for our component, get component, just try to get sphere. Here we are. So now we've got our sphere reference, exact same sphere in here. Now we can we can test if they equal each other. So now, instead of it searching for the entire actor, it will see if we're inside our Goomba zone. Sorry, see if we're inside our greenbox toggle. And actually, this will scale with multiple greenbox toggles as well, so we can mess about with that later. But as it stands, so now we just need to do our branch as we did before with our over here. Just going to do a test of, is it touching, basically? Are we about to Goomba on our sphere? Now, if it does, but before we do the next step, because we're about to call our attacked function, but our blueprint doesn't know to use our BPI underscore combat. So we need to tell it to. So go to your class settings, sort of in the top middle leftish. There on the right hand side there is interfaces. So we're just going to add our BPI underscore combat interface. Hit compile, save. Now, this next part is really finicky for no reason, and I hate it. So, as it stands, when you go to attacked, there are 3. And you have no clue which one is the one you want. So, event attacked. So, actually, for the purpose of this tutorial, we can just get all 3. Now, for some reason, none of these are the one we want. And I'll still never be entirely sure why it's so weirdly finicky and just doesn't want to work. The correct one we want is specific. Is not a function call, but it's a message. So let's try message. Right, tag. Nope. Okay, so let's try disabling context sensitive. Now let's try attacked. Here we go, message. So to get it to work, you need to disable context sensitive. No idea why, makes no sense, and it's caused me so much grief. So now, that's right, you can send a message to a certain target, and that target will be our overlapped actor. Now, our nodes are starting to get a bit messy and a bit ugly. And instead of having to push them all out of the way to try and make it make sense, there is a really useful thing you can do to keep your nodes nice and clean, which is simply double-clicking on one of the streamline things. If you double-click it, it creates this little node of its own, and you can just use that to tidy your thing. For the sake of this, I am going that as is. Instead, move this way. Now, when we zoom out, it sort of makes sense. Okay, so this all works now. I think, if I'm right, we are finished with our third person character. Let's head back to our green box toggle. Now, first things first, we need to make sure it's also listening for the. So BPI underscore combat. File and save. Now, this time, because we've got it, so we've got our third person character sending a message that the attacked event is happening. That's what it's telling it to do. So here, we're simply getting our event attacked. Now, if it doesn't appear for you, it's because you need to compile. Every time you make a change in like one of the settings variable, you need to compile for it to apply. So for example here, we've created a new variable, but we can't change our default value yet because we compile the blueprint. Now we can. We don't actually need that variable, that was just... So, this event attacked event will trigger when our sphere has been goombed. So, if we had a really complicated health system or all of that, blah blah blah, we could have it do that. For now, we're just going to have it push our player a little bit upwards so they get a bit of a bouncy feedback, and then destroy the actor. So, we're going to want it to... Nope. Here we are, launch character. So that's what we're going to want to reference. But, as it stands, it doesn't appear. The reason it doesn't appear is because in our third person character, there's a character movement thing, C++ class. But it's not in here because it doesn't think it needs it. So first things first is we're going to cast to our player character. What's it called? Third character. And for our object reference here, we can simply just use our player character. We have to do. There's other ways you can get the reference, but we only have one player, so no worries. File and save. Now, what should we do next? Cast a third person character. So here is where we want to get launch. Launch character. So now we have basically, so we can basically control our entire third person character blueprint in here because of this cast, which makes it super useful for containing all of your important mechanics onto a single blueprint. You're right, Alga? Do you have a question or are you right? I assume you're fine.
No, I'm good.
We're good? Sorted.
Yeah.
Okay. So our launch velocity, let's just make it, say, 50 up. That might be too strong, I'm not entirely sure. So, now, when event attack is triggered, we have it all do. Yeah. Okay, so we're launching the character, and now all that's left to do is for us to kill our thing. So, there's a few ways you could do this. You can either deactivate the mesh and keep the actor alive, which is literally up to you. Personally, I'm just going to destroy actor target self. Now, it might scream at me and it might yell at me because Unreal doesn't really like it if you destroy actors in certain ways. For now, let's see if this works. Really hope this works. Did not work. Now, why is it not working? So, object on component begin. Wait. Why aren't we? Oh, we're standing on the... Okay, I must have messed about with our collisions. So trigger. Oh, that's why it's blocking our player. So custom, and we want it to overlap up. Now let's try. There we go. So our Goomba Stomp was pretty pathetic. So let's go back into our Goomba Stomp value and let's make it something like 200. Hope it works. What? Okay, so it doesn't seem to be having any effect on our character. Oh, this was actually a problem I was encountering a few days ago. For some reason, launch doesn't seem to want to work when you're falling, when you're in midair. I think if we do Z override, fix it. There we are, perfect. So you see we did a little bounce. But it was still a bit too underwhelming. Let's try 600. Oh, that's a bit too high. But this should work with multiple instances. So toggling this one on and off, and I'm going to bounce on this. Ooh, let's get a little pop going. Oh, I'm a gamer. Yeah, and that's how you use a interface blueprint to communicate between blueprints. But that's not all it can do. So if we go back inside, we can make one of our inputs damage value, and we can make it an integer. And obviously, Ah, no, never mind, I'm being dumb. We should only need the 1. So just an input of damage value. So, go back to here. Ah, perfect, here we are. So now, let's create a variable called hit points. So we're going to make a very rudimentary health system. And we want it to be integers, not floats, because we're dealing with whole numbers. Compile, so we can save our default hit value. And let's say each ball has 2 health by default. So instead of us Goombaing and immediately destroying the actor, what we instead want it to do is, first off we want to get our hit point, and we'll run a branch. Now, do our hit points equal 1? If they don't, we want it to set our hit points to be our current hit points minus 1. So we've taken 1 damage if we're not about to die. If we are about to die, so if we only have 1 hit point left, instead we want it to destroy actor. Okay, so actually we didn't even need our damage value. But if we did, then we would plug our damage value into here, our save, and then in our third person character, we'd say, create, say, a new variable, Goomba damage, and that would just be an integer. And if we want to, like, oh, actually no, because this wouldn't scale right. Okay, so let's go back into here. closing these. So if we go back into green box, instead we want to, so if our, okay, so what we actually wanted to do is we wanted to set this first, so to set our hit points. So now, instead of it testing if it's exactly 1, we want it to test if it's less than or equal to 0. And that will test if we are dead or not, basically.
That's greater than.
Sorry?
That's greater than.
Ah, yes it is. Right. Less than greater. I was getting mixed up. Okay, so, and with that, if our hit points, if we've run out of health, true. If we haven't run out of health, then nothing happens, because we've already set our new HP. Save. So now, if we have our Goomba damage at 1, then you can see it should be 2 bounces and then they die. Oh. Did I forget to plug it in? Ah, I forgot to plug it in, that's why. Plug Goomba down. Our attack message in our third person character. Now let's try again. 1, 2. Perfect. Now, let's do a cheeky bit of construction scripting. So let's go back into our green box toggle, and we are going to create a set hit points. Actually, no, we don't need to. Never mind, it doesn't need to be in our script. We can just expose the variable. So by clicking this little symbol next to our variables in the bottom left, it exposes it. Variable is public, but so tooltips aren't mandatory. It's just yeah, hit points is fairly self-explanatory. So now you'll notice on each of these things we can set each individual instance of the object's hit points, which is very useful if you want to make some slight variations in the same enemy class. Now, this should only take 1. This should take 2. This should take 3. I'm just a wizard at this. Yeah, and let's test if it works if our Goomba damage is something. Oh, I think my Unreal's just frozen. Oh, alright, we're back. Alright, Goomba damage, let's set it to 5. So now, hopefully, all of these should die in the first shot. That worked. That worked. And that sort of worked. The reason it happened before I landed on it was simply because of the way I've set up our box collision. So you can see in certain parts it actually goes outside our capsule collider. Easy way to fix that is to either use another sphere collision or just make. Yeah, I think I've shown off dynamic materials and blueprint communication. So all that's left is customizing the player character itself. So this isn't going to be anything blueprinting or anything too big brain. I'm just going to be walking you through all of this. Well, most of it. The only parts you'll have fun tweaking. So, as it stands, actually, we don't need to do it in blueprint. We can do it. We delete our network player start. If we have our character instanced here, then we can interact with the right here. So, most of these are fairly self-explanatory, but just for the sake of it, I'm going to be showing a few off. So max acceleration is obviously how fast you can go, or rather how fast your input can let you go. Mass is just weight and all of that. All of this fairly simple. Things you may want to be tweaking are your max walk speeds. The default third-person character doesn't have any built-in sprinting system. I could show you how to do that if you guys wanted. But let's say, so let's just change it to, so we're going to move at twice the speed. Now, that doesn't seem to have changed. Wait. Ah, that's why. So, we're not using that character, we're still spawning our own one in. Yeah, okay. So when you, so sometimes this can happen. So we have our third-person character, but we're not automatically possessing it. So what you can do to fix that is, I've forgotten the something. Ah, activation. Here we go. Auto activate. That's all right. Something about input. Ah, pawn. Here we go. So, kind of. So we want to auto possess player 0, which is player 1, and yeah, that should be it. Right now, perfect. So now we're controlling this one, and we should. So there we go. Because we've changed our max movement speed, we're moving a lot faster. So to prevent from having to do what I just did, you would go into your blueprint and you would go to character movement and you would change the walk speed here. Acceleration just determines how quickly you get up to your max walk speed. So if I set it to something like 512, there should be a gradual build up. There you go.
Dude, I didn't know that. Thank you.
Well, there you go, Tom. See? I'm even teaching the fancy spy guy what to do. Okay. Not really entirely sure what else to show off with the character. Oh, actually, I could make them slippery. Not exactly slippery, but we could... Where is deceleration? Here we are, ground friction. So, you may notice certain games, when they stop running, they have a little, like, a little bit of time to slow down if they have a lot of momentum behind them. And this would be how you do it. So, make it 4, so stop pressing. And it still feels pretty tight. Probably want to make it like something like 1. Need to stop doing that. Friction do. Braking, this property allows you to... Oh, so is it how quickly you can turn? Ah, okay, so ground friction determines how quickly you can turn. So if you wanted to make an ice level, this is how you do it. It doesn't determine how quickly you stop. That is determined by just simply braking deceleration. So set that to 512. So now, oh, this feels horrible. So as it stands, it just looks like our character is slowing, but I stopped pushing a short while ago. But that's how you would have your character have a little slow. So if you want your controls to feel like they have a bit of weight and not so tight, you would have it be something like possibly like that maybe. So yeah, so it still feels like I'm slowing out. I need to fix the brake acceleration. So yeah, you can still feel like you have a little bit of stop. Like you're still stopping fairly sharply. Oh. What? Try making it 512. Okay, so it seems like ground friction and braking deceleration seem to have very similar effects. So you're probably going to want to use some sort of combination of the two to get the exact effect you want. Oh, another thing. You may notice, if we spawn another actor in, if you jump on top of them, it sort of bounces you off. And the reason for that is because in our blueprint, there is a simple thing in our capsule called character can step up on. So basically that just forces whatever collider to see if it's like basically forces the player to get off it or not. So if you had like say a pole that like, oh, it's really fancy, but if your player is able to jump up on it, then they'd be able to hop out of your level and it would just break everything. So to solve that, you would simply just go into collision. Character can step on. No. It doesn't work. Well, sometimes it works, sometimes it doesn't. I think it needs to have a specific collider. It doesn't work with mesh collisions. So actually, let's test that. Let's create a box. Let's just create a basic. Maybe it only works with capsules. But yeah, so that's how you would do a feature if it worked. Settings. I feel like we've had a fair bit of another thing. So a bunch of you may want to mess about with the jump. So jump Z velocity basically determines the force of which you go upwards, and air control determines how much you can move midair. So if you want to get some like cool sort of CS:GO style strafing, then I don't know, maybe you'd have it at 0.5. So that way you can like stop yourself midair. So you can like. So by default, I need to this again. Okay. So air control, if we make it 1, we should have full control. So still not great. We've got pretty good control. Try making it. What happens if we make it higher? Okay, so the effect seems to be clamped. So 1 is the highest you can. So jump Z velocity. Jump twice as high. Yeah. Is there any questions or I'm probably going to be around for maybe another half hour because I haven't eaten today and I'm starving. Are there any questions or any other features anyone wants me to touch on before I go? Did I put everyone to sleep?
I mean, I want to catch you after I eat to just, if you can help me brainstorm what else I can do with my mechanic, but because I don't know what else I want to do to it, I don't have any.
Okay, well,
we could talk about.
What's your mechanic? It's some sort of power-up, isn't it?
Yeah, so basically I have 3 different pickup buffs, and they spawn in one of 14 random points on the map, which are not repeatable, and then get one of the 3 buff types that then affect the character. There's an invis one, there's a jump one, and there's a speed one. And I have the buffs. I have made sure that you can't get another buff while one of them is active. The spawns don't repeat, but besides making them, because I've made them rotate and bob and made them pretty and made it so that after you get the buff, the starry pickups, the mesh is destroyed. No, well, fragmented, and then it destroys the blueprint so that they despawn. but I don't know what else I could actually add to it because I feel like I still don't have enough for the submission.
Have you made the power-ups actually work?
Yeah.
Well, then that sounds pretty good to me. Oh, actually, a fun little thing you could do is are your power-ups colored at all?
Yeah, they are. That's so I have like a base emissive and then I just made it into a parameter so that they spawn depending on what pickup type you have, the emissive color changes, and it also gives a when you get the buff you also get a material on, or well, either the new material or the parameter change on the character material so that you can, so when you're fast you're glowing green and when you're jumping up really high up you're blue and
That's a shame. That was going to be what I recommended to you. I was about to show you how to do Fresnels. So Fresnel, for those of you that are curious, is basically an outline glow.
Oh, they're not outlined. I actually wanted to do outlines, and the only tutorial I found was duplicating was using a child mesh, and I didn't want to do that.
Oh no, there's a super easy way of doing it.
Okay, that's cool then.
If you want it, okay, so there's sort of two air quotes types of glows. There is the glow, where the light goes outside of the character, which is very difficult to do. The super easy and super cheap method is a Fresnel, which basically takes the outline of the player and makes it glow slightly inwards, sort of like an inner glow and outer glow in Photoshop. So, let's create. Actually, it doesn't really matter. So we can just do it here. So, let's just make a Fresnel. So, all these words are very confusing, and even to me now, as someone that loves Fresnels and uses them all the time, I still don't quite understand what they mean. From my understanding, so as you can see, we've already got our sort of dark in the middle, bright on the outside. So, from my understanding, exponent in is the sort of how bright it is in the middle, and our base reflect fraction in is our value for how sharp the edge is. So if we make it something like 0.1, just 1. I've got them the wrong way around. Okay. So let's make another multiply, have that plugged in, and our exponent, have that plugged into emissive color. There we go. So that looks really cool to me. So, I think something like 0.1. Make that really sharp. Nope. The opposite. There you are. Okay, so the bigger the value on exponent in is how sharp the outline edge is. And if you do a bit of creativeness here, yeah, so I'm not sure where it caps out. It's something like it caps out at 0.1, so if we go 0.5, yeah, so it's sort of half brightness in the middle. Change it again. Change it one more time. I promise you this does work. It's because we've got this multiply making it super bright. So yeah, so base reflect fraction in determines how bright what the Fresnel opacity is of things that aren't on the edge of view. Now, a super useful feature that will make it all look super professional and super neat is if we make these parameters, so fraction in, and call this exponent in. We don't really need the normal. I've never felt the need to use it. Because if you just have normal applied into here, then it works anyway. Okay, so this all works, this is all fancy. So save. Go over to our material instance, so you can see it's updated, and we can mess about with the material very exactly here. as you can see in world, that oh, these look cool.
That's really handy.
But a super useful thing that I was going to show you specifically for your benefit, Deanna, is material functions. And this will be super necessary for you because I imagine you're working with multiple materials on your characters.
Mhm.
So what you can do is so basically cut. So we just want the Fresnel emissive. That's all we want. So we don't need our base color. Let's tidy this up slightly. I'm going to change this name to brightness because we don't care about anything else working now. So this is how I would do it, and this is how I have done it. So now I'm just going to Control X that because we don't need it anymore, or at least we don't need it in its current state. So I'm going to go to our thing here and go to Materials and Textures. And I'm going to create a material function. So mf underscore glow, let's call it. And I'm just going to Control V. Plug that in. And it's going to have the exact same effect it had before. Except this time, if we go back into our thing here, just set a thing for base color again. This time, we can just do mf underscore. Or not. Did we save it? Save. MF. Okay, so for some reason it's not appearing, but if you just drag and drop it in, now all of those nodes are condensed and reusable, and just plug them into your emissive. And if we save, because our parameters are still in our material function, effectively our material instance hasn't changed. The parameters are still there, but they're not clogging up our main master material. And this is really good because imagine you have 3 materials on one character and you have several characters. Instead of having to copy and paste all of those nodes all the time and just getting really messy and cloggy with it, instead you can just go to your thing and just add glow. And then just plug that into whatever existing emissives you've got, and it just works. Super easy to use.
Thank you.
That's alright. Does anyone else need any help? I'm going to quickly fix this because I missed it looking cool. Right, well, I think that concludes my recording. We've gone on for about an hour and a half now, so that seems like a fair time to end. Thanks everyone for participating. I hope it was useful. If you wouldn't mind, show me some of the work you did so I know it was actually useful. That'd be great. And I'm gonna log off now. Have a great time and have a great night, guys.
Thank you.
Thank
Thank
you.
you.
That's alright!
Thank you.
Alright, stop recording. I'm gonna quickly check